right, guys, so we're going to call these notes balancing reactions. And the first question that I'm going to ask you is, why do we balance? I'm going to give you an equation here. Can you guys see that? Why do we balance? Let's see if that contrast is better. So, say for instance I have this equation, N2 plus H2 yields NH3. That equation as written is incorrect. Well, what's the problem? I know it's not balanced, but why do we balance? How many nitrogens do I have here on the left-hand side? 2. How many on the right? 1. Oh, did one atom magically disappear from the universe? All right. What about here? How many hydrogens do you have there? 2. How many hydrogens do you have there? So, did a hydrogen magically appear? Did the nitrogen turn into a hydrogen? That is magic. What's wrong?
It's not supposed to be like that.
How is it supposed to be?
It's supposed to be like, ask my friend Kim.
It's supposed to be N2 plus H2 equals N2H.
No.
It should be
No.
NH, because they cancel out.
Yeah, but what's the problem here? Keanu, what you know? Okay. What's the problem?
This doesn't add up.
I'm breaking the number 1 law in chemistry.
Don't change things. Things
Okay.
can't change.
Did I not just like explain to you that we made something disappear and something appear?
Oh, you can't just make
Well,
up stuff.
you can't just make up stuff. Lavoisier gave us this law, right? The first fundamental law in chemistry that's called the law of conservation of matter. What does that law state?
Oh, I got this.
Yeah.
So things can't be like destroyed or created. It's just
Well,
like
okay, so
transferred through.
right now, you're right. You can't destroy or create them. So, but right now, the way I wrote that equation, I'm implying that something's being destroyed or created. So that's the first problem. The reason why we balance is because if you don't, you will break the law of conservation of matter. So we balance to obey that law. All right, so let me show you how to balance this. So you wouldn't leave the equation like that. What you really should do is, and I'm going to do this in pencil. So you see how there's 2 hydrogens there? I'm sorry, 2 nitrogens there, but only 1 there? So I would put a 2 in front, right? Now I've got 2 nitrogens on both sides.
We have 6 hydrogens.
And now that gives me 6 hydrogens, and then so I can fix it by putting a 3 there. All right? And so what we're going to do is we're going to play with coefficients. You don't play with the little subscripts anymore, because if you do, like say for instance I changed that to a 6, would that be ammonia any longer? No. You don't play with the subscripts anymore because that changes the identity of the compound. You only play with coefficients. And what I have now is something that's really super useful. All right? Because what these coefficients tell me now is a recipe. All right? So now I know that if I want to make ammonia, which is a really important industrial fertilizer, I would need to take 1 part nitrogen, 3 parts hydrogen. It's going to give me 2 parts ammonia. I've got a recipe. So the reason why we balance is to derive a recipe for making the product. And the only way you get that recipe is to balance. All right? So now the question is, how do we balance? Well, what did you see me do?
You added stuff.
What kind of stuff did I add? Coefficients. So you add coefficients.
They will only balance it.
Yes.
There's no other way.
And where did I put those coefficients?
In front
in front of the whole substance, right? I didn't stick that 2 in between the nitrogen and the hydrogen, right? I didn't play with little subscripts. You add coefficients in front of substances. In front of, that's important. For what purpose? What was I trying to do? Wasn't I trying to get the number of atoms equal on both sides? Alright? So I added coefficients in front of substances to get the number of atoms of each element equal on both sides of the arrow. Evan, if you have to come up front, there's a chair up front. Yeah. Let's see. All right, so we're going to start by using an atom inventory. I'm going to show you how to use an atom inventory, but know that this is just a technique. If for some reason the atom inventory doesn't work for you and you think it's a waste of time, and you can just figure out what the coefficients are by simply looking at the equation, then skip the atom inventory. Okay? I like to start by teaching students how to do an atom inventory just in the beginning so they can get the hang of what we're doing. Okay? But ultimately you want to wean yourself off of these. Okay? Alright, so let me show you how to do it for that equation that we had on top. Alright? So we start with a reaction. Okay. First thing that I'm going to do, I'm going to write some steps here on the right hand side. I'm going to make a table, and I'm going to list the elements on the left hand side. Okay? And the table is going to have a little line. I'm going to just draw a vertical line underneath the arrow. Okay? Because I want to figure out how many atoms there are on the reactant side and how many atoms there are on the product side. Because I've got to make that equal. I've got to make the atoms on the reactant side equal to the atoms on the product side. Alright, so what elements do you have present here in that equation?
We have nitrogen, hydrogen.
Alright, so nitrogen and hydrogen. So I'm going to list those on the left-hand side. Alright, so number 2. I'm going to count how many atoms there are prior to balancing. On each side. Prior to balancing. Alright, so scooch that paper up. How many nitrogens do you see here? 2. How many nitrogens do you see there? 1. How many hydrogens do you see there?
2.
How many hydrogens do you see there? 3. Okay, well here's the problem. They're not equal. I need them to be equal. Alright? And so that's where the balancing part comes in. So number 3. I think it might be easier for us to look at the hydrogen first, rather than the nitrogen. You shouldn't necessarily go in order. What I need to figure out is what number to multiply this by, and what number to multiply this by to make them equal to each other. What? What are you going to multiply this by? A 3. And that has to be by 2. Because 2 times 3 is 6. 3 times 2 is 6. So you're going to figure out what to multiply each side by. To get both sides equal. Alright? Okay, I'm going to put number 4 over here because I'm out of room. right, so that number that you came up with, that 3, that's going to be the coefficient that goes in front of the substance that has the hydrogen on the left-hand side. All right? So I'm going to put the 3 right here. And that 2 over there, that's going to be the coefficient that goes in front of the substance that has the hydrogen on the right-hand side. So this is a substance that has the hydrogen on the right-hand side. So I'm going to put that 2 in front of it. Okay, so number 4, what did I just do? So the factor that I just came up with, in step 3 is the coefficient that goes in front of the substance that contains that element that you were working on. All right? So let's take a look real quick. When I put that 2, I put a 3 here, right? How many hydrogens did it give me? 6, all right. When I put that 2 there, how many hydrogens did it give me? 6. Now, by putting a 2, did that not change the count for my nitrogens? Yeah, it did. How many nitrogens do I have now? 2. So I should have changed that to a 2. Are my nitrogens equal? Yeah? Are my hydrogens equal? I'm balanced. I'm obeying the law now. Okay? Before we go on, though, I want to show you some of these, something very particular, because I think this is going to be critical for you to understand how this all works out. All right. Let's practice something real quick. All right. So 2 in front of NH3 is the same thing as putting a 2 in front of a binomial like this one in your algebra class, right? What does this mean? It means for you to distribute, right? So if you have a 2 in front of the NH3, that means that you are, and when you distribute, what mathematical operation are you performing? You're multiplying, right? Same thing here. If you have a 2 in front of the NH3, the 2 goes to the nitrogen. The 2 also goes to the hydrogen. So how many nitrogens do you have here? Nitrogens. There's 2 of them. How many hydrogens do you have in this formula? How many? 6. Okay. All right. What if I had a formula such as this one? And this is something I was a little bit kind of perplexed by because second period had an issue with this. All right. How many sodiums are in this? How many chlorines are in this? How many oxygens are in that? So some people were asking me, does the 2 only go to the oxygen? Yeah. They wanted to distribute the 2 into the chlorine into the sodium. No. That 2 belongs just to the element that it's attached to. But a 2 in front, you distribute. Okay, let me show you one more thing. What if I had this? All right. Yeah, oh my. Let's not look at this for a moment. What if I had a polyatomic ion in parentheses and you have a little subscript 2 on the outside? What does that little 2 on the outside mean? You distribute it in. Okay? So this you would distribute in, and then you got a 2 in front, so guess what we do there as well? You distribute as well. Okay? Now, does that 2 on the outside, does that get distributed into both the oxygen and the phosphorus? Yeah. Okay. And what about the 2 here? What does that get distributed to? The magnesium, the phosphorus, and the oxygen. All right? So let's take a look. How many magnesiums are in this formula? There's 6. How many phosphorus are there in this formula? There's 4. How many oxygens are there in this formula? 16. Right? So magnesium, the reason why you have 6, It's because you've got a 3 attached to it, and you do 2 times 3. All right, give me a second, Evan. The phosphorus, you distribute the 2. You distribute the 2. 2 times 2 is 4. For the oxygen, you distribute the 2, so 4 times 2 is 8. You distribute the 2, 8 times 2 is 16. Evan, what do you mean? No, these little subscripts came up because of the charges. Okay? All right, so that's kind of important. That math, that distribution is important when you're coming up with these balancing things because it helps you figure out what numbers to put in front. All right, so now I want to practice. I want to practice this quite a bit. And I want you to do some of this balancing before I teach you any sort of strategy whatsoever. Okay? Because I want you to see how stupid it is to hunt and peck at answers. I want you to struggle with that for a little bit, and then we'll look at what you can produce simply by hunting and pecking. And then after that, I'll show you that there are better ways to do this. Okay? All right, so let's start with something simple. Nick, do me a favor. You see that paper that's attached on the board? Can you hand me that, please? Now I want you to practice this. Thank you, honey. Okay, let's try this one. So P4 plus O2 yields P2O5. That's a 4, yes. So what's the first thing that I told you to do in the atom inventory method?
You have to make a list.
Make a little table, right?
P and O.
P and O. How many P's on the left? 4.
There's 2 O's.
And 2 on the right? 2 O's?
Yes.
Okay. How many P's on the right?
There's 2.
2. And then how many O's on the right?
5.
5. Okay. My suggestion to you, this is math, right?
Yeah.
I would never do math with a pen.
So we
If you're working with a pen, switch to a pencil, please. All right. So,
need to get 5. 5 times 6.
okay. So let's figure out how to make P's equal. What would you do to make the P's equal?
5 times 6. Times by the...
Well, wait a minute. Wait. You want to do the oxygen first?
Yeah, I did.
All right. We can do the oxygen first. So what do you want to do here?
2 times 5.
Multiply this by 5, and then what do you want to do there?
Times 2.
Multiply this by 2. So that means that you would have to put a 5 in front of the O2 on the left, and then a 2 in front of the P2O5 on the right. I had students last period that wanted to put the 2 here in the middle. Don't. It has to be in the front. Okay? All right. Now, this is equal. But in the process of putting that 2 there, what did I do to the P?
16 maybe.
I made it into a 4.
Now
So now they're both equal,
yeah.
and I'm done. All right? Okay. Now, Keanu, don't gloat because I'm about to make them harder. Okay. Okay, let's try another one. Okay, same reactants, P4 plus O2. Oh, but look, they make a different substance. They make P2O3.
Easily. So you make P, and then make O with this thing.
P and O,
And there's
4, 2, and then on the right side there's
2 and 3.
2 and 3. Okay.
Equal out the O.
Uh-huh.
You're going to do 2 times 3.
2 times 3,
Times 3, and then you do 3 times 2.
3 times 2.
So then you're going to put
Okay.
the 3 in front of the O on the left side.
Okay.
And then you're going to put a 2 in front of the P2O3.
On the right side,
Yeah. And
Okay.
then that's going to make the P into a 4.
it's going to make the P into a 4.
Yeah, and you're done.
And so then we're equal. We're equal. Do you guys see that?
Oh, don't look, Johnny. You can't.
Yes, Evan. Yeah. Keanu, you went too fast for him. Okay. Okay. I know, Keanu, it is a curse to be so bright. All right, look. You see how this is a 2 and this is a 3? Okay, the question is, what would you have to multiply this by and multiply that by to make these equal to each other. So you have to multiply this by a 3 and that by a 2. All right, so the 3 is the coefficient that goes in front of the oxygen on this side, right? The 2 is the coefficient that goes in front of the oxygen on that side. And it's not in front of the oxygen, it's in front of the compound that contains the oxygen. So you put a 2 there, all right? You put it in front, not in the middle, not in between. And you don't change these little numbers anymore. All right, now, by putting a 2 there, right, my oxygens are now equal, but now doesn't that get distributed into the phosphorus now? So how does that change my phosphorus count? It makes it a 4. Are my 4s equal now? Yeah. All right.
Give me a hard one.
I'm getting there. Okay, here we go. Next. You want it hard?
Really hard.
Okay, let's see. Let's see what I can do for you. This one's not that terribly hard, but
Alright, they right after.
okay. You're saying I ramble?
No, I said Rambo.
No.
Condom. So you have N. Wait, they're all
Oh,
NA.
guys, why don't you do it quietly?
You have to do NA. You have to do NA.
Do it. Do it on paper. Let everyone else think a little bit. You're going a little too fast. Caleb, you have an answer? What do you mean you don't know? You put your pencil down. Are you happy with your answer? What do you mean you're not really happy with your answer?
It's exactly. I like this spicy up.
All right. So what are the elements here? Na and N. All right. So there's 3 NAs on the left and then 1 on the right. How many nitrogens on the left? 1. And how many nitrogens on the right? Okay, so we're not equal. All right, so what do you want to start with? The sodium or the nitrogen? You want to do sodium? We can. Now, some of this is going to be trial and error, which is not my favorite thing to do. I don't like walking into things without a strategy. So right now, if you think about it, you would have to multiply this by a 1 and multiply this by a 3 to make them equal, right? Okay, so let's go ahead and put a 1 here and a 3 there. Okay?
I just left the ones blank.
You can't. I would prefer that you leave them blank. Okay, but just be aware that if there's nothing there, technically speaking, there's a 1. All right? Okay, here's the problem, though, right? Are your nitrogens balanced? Maybe we shouldn't have started with sodium. Maybe we should have started with the nitrogen instead. That's what you did? All right, so how do we fix the nitrogens? I'm going to multiply this one by 2. All right, but I had already multiplied it by 1. So 1 times 2 is 2. All right. Now, by putting a 2 here, my nitrogens are equal, but what did that do to the sodium count? It changed it to it's really a 6. Okay? All right, now, so this was wrong. I shouldn't have done the sodium first. I should have done the nitrogen first. How do I get sodium equal now? Multiply it by 6. So I put a 6 here in front. I'm equal. Okay? All right, let me give you something a bit harder. Okay, so up until now I've given you equations with 2 elements in it, and I'm going to give you 3. Have fun. If you But you might be hunting and pecking at answers, and you might come up with an answer for one thing and find that later on you're gonna have to change it to fix something else. I know you don't like doing that, and I don't like you doing that either. But right now I'm gonna do it. Because there's a reason why I'm asking you to do this as well. Just randomly picking numbers. I don't like that. Oh yeah. Yeah. Your hydrogen's wrong. How many hydrogens do you have here?
Oh, yeah.
You don't
Oh, yeah.
have that many. You
I
have
got
right.
it. I got it.
You do? Yeah. Okay, I'm coming. For your aluminum people, so don't focus on this, right? So go to the hydrogen next. How do you fix the hydrogen? Okay, so put it here. All right, guys. So some of you guys are struggling with this, huh? Okay. Yeah. Got it. Okay, all right. Now, hey, two problems. Number one, I think sometimes the table is cumbersome. Right? Number two, you're trying to do this without a strategy. You're just going willy-nilly and picking numbers and seeing what works. I hate that. I think that's such a waste of time. All right, so let's take a look at how you could do this. Can we skip the table? I think the table is confusing. All right? Okay, if you like the table and it helps to organize your thoughts, fine, do it. But I'm going to show you how I do it. Because after a while, you want to wean yourself off the table, and you can just look at these things and tell what you need to do. All right, so now, are my aluminums equal?
Yeah.
Yeah, don't worry about those. Skip over them. Are your hydrogens equal? No. So how do I fix it? Well, no. How do I fix it right now? I'm just looking at the hydrogens. I'm going to put a 2 in front. Okay? All right, now. So far, my aluminum's taken care of, my hydrogen's taken care of. But what about the chlorines? No. Because how many chlorines do I have here on the left-hand side? No. This distributes, right? There's 2 chlorines. How many chlorines do I have on the right-hand side? 3. How can I make them equal? It really should be 6 on both sides, right? So I should not have put a 2 there. What should I put instead? I should have put a 6 instead. So I'm going to change it. All right? Now, my aluminums are still balanced, right? How am I going to get the chlorines to balance now? I have to put a 2 in front. My chlorines are balanced. but my hydrogens are off, right? How many hydrogens do I have on the left-hand side? 6. How many do I have on the right-hand side? What do I do to fix it? Put a 3 in front.
Oh, you can do that?
Yes,
But I
sir.
had it.
Okay, so it's 1, 6, 2, 3. It's a lot quicker than doing a table. Could you have done the same thing by doing the table? Sure, right? So you make a list of the elements here, right? You've got aluminum, you've got hydrogen, you have chlorine. You've got 1 aluminum, 1 hydrogen, 1 chlorine. Here you've got 1 aluminum, 2 hydrogens, 3 chlorines. So, but it's the same process, right? So you first start out by saying to yourself, okay, this isn't equal, so I'm going to have to multiply this by 2 to fix it. This isn't equal, so I'm going to have to multiply this by 3 to fix it. All right, so now that means that you're going to have to take the substance that has the H and put a 2 in front of it, and then you have to take the substance that has a Cl and put a 3 in front of it. All right? Now, so what number do you put in front? Do you put the 2 or the 3? You don't. You multiply them. It's the multiple. What's 2 times 3? 6. All right, and then over here you did nothing. All right? So that's how you can do this particular thing with the table. All right? Now, yes, ma'am. Do I need to put a 2 in? Yeah, because now by putting the 2 there, you're right. I forgot. That throws off my aluminum count over here to 2, and then that means that you have to multiply this guy by 2. You're right, Lexi. Okay? So I would have to put a 2 there. In all honesty, I think it's just so much easier to just look at the equation, look at both sides. I put my finger underneath each element on both sides, and if it's equal, I put a check mark to know that I'm done, and I move to the next thing. And if I have to go back and change things back and forth, great. Now, that took a little bit longer than I would have liked, because we're kind of doing this willy-nilly with no real strategy. We don't have time for that. All right? So let's just take some more notes. When balancing, you really should use a strategy to save on time. All right? Here's the strategy. So I want you to label this strategies for saving time on balancing, or strategies for balancing. So strategies for balancing. Underneath these practice problems. Okay. All right, so in order to make my life a little bit easier, because sometimes you can sit here like for 5-10 minutes playing with numbers back and forth and still not getting them balanced. To make my life easier and the duration of the amount of time that I spend on these things shorter, I follow some steps, okay? The order in which you balance things might make the difference between you taking half an hour to do it and 30 seconds to do it, all right? So usually when I'm balancing, I usually start by balancing nonmetals, all right? And then I balance metals. And if there's oxygen and hydrogen in the formula, I usually save those for last. There's a reason for that. More often than not, oxygen and hydrogen show up on multiple formulas on both sides of the arrow. It's too fragmented. I save them for last. If you save them for last, if you fix the metals and the nonmetals first, 9 times out of 10, the oxygens and hydrogens are fixed by default. You don't have to do anything to fix them. Okay? All right, so usually start with the nonmetals, then do the metals, then look at the oxygen and the hydrogen. Here's some other things you should consider when balancing. All right? If you have a polyatomic ion, and it shows up in the exact same format on both sides of the arrow, balance it as if it were a whole unit. And I'm going to erase, oh, I can't, it's an ink poop. Hang on. For last. Okay, so here's an example. I want you to write down this example. So I've got sodium phosphate and barium chloride, and it makes barium phosphate and sodium chloride. What should we balance first? Okay, so which nonmetal are we going to go after here? Not the nonmetal in the polyatomic. I'm going to go with chlorine first. Alright? And I'm not going to use the table, because if I do the table, I've got 1, 2, 3, 4, 5 elements. It's going to be a big table. There's no need for that. Alright? So, look at the chlorine. How many chlorines on the left? How many on the right? 1. How do I fix it? Put a 2 in front. Okay? Alright, now, step 2. After I balance the nonmetals outside of things in polyatomics or oxygen and hydrogen, then what do I go after? The metals. Okay, well I've got a couple of metals here, right? Okay, so let's start with the sodium, right? How many sodiums do I have here on the left? 3, and how many do I have on the right? 2. What should I really make it? I really should make these 6. So how do I make this a 6? Put a 2 in front, and then what about here? I should really change that, shouldn't I? I should change it to a 6. Oh, but then that just messed me up on the chlorine that I thought I had fixed. So what is the chlorine? How do I fix the chlorine now? Put a 3 in front. Okay, there were 2 metals in this formula. The sodium is 1, right? That's fixed. I took care of that nonmetal. Isn't barium a metal too? Yeah. Is it fixed? I've got how many bariums on the left? How many on the right? Okay. And then the last thing that I have to solve for is the polyatomic ion phosphate, right? So look, I want you to not think about it as phosphorus and oxygen individually. I want you to think of it as one whole unit, all right? How many phosphates do I have here on the left-hand side? No, I got 2 of them. This is 1 unit, and there's a 2 in front, right? So 2 times 1 is 2. How many phosphates, how many of those units do you have on the right-hand side? 2. So phosphates balanced, we're done. Okay? That's it. All right. Here's the last strategy that I want you to think about. The last one that I want you to think about. Sometimes I'm looking at these equations and I get stuck, and the way that I unfreeze my brain is to implement this strategy. So if an atom is in odd numbers on one side and even numbers on the other side, start by making both sides even. And what's the easiest way to take a number and make it even? Multiply by 2. All right? So here's an example of that. So look at the oxygen here. It's even on the left side, but what is it on the right-hand side? It's odd on the right-hand side, right? Okay. What did I just say? What's the easiest way to make something even? Multiply it by 2. So start by making both sides even. Now I've got an even number of oxygens. Can I fix that there? How many oxygens do I have here now? 6. How do I get 6 there? Well, wait a minute, a 6? Put a 3 in front, because 3 times 2 is 6, right? And now what's left to do? Put a 4 in front of the Fe. Okay? All right, last thing that we're going to write down in our notes before we do this balancing worksheet and I turn the lights on and I walk around and help you guys with this. And this, I want you to highlight, star it, circle it. This is important. When you're done balancing, make sure the coefficients are all reduced to lowest terms. So, for example, if you had an equation that looked like this, 2a plus 4b yields 6c, you really shouldn't leave those coefficients like that. What should you really write it as? You should really write a plus 2b yields 3c. Now, when you factor out a number, you have to factor it out of every last substance in that equation. So if you had the equation 2a plus 4b yields 6c plus a d, you wouldn't be able to reduce that, would you? How come? Because of the d, right? You can divide 2 out of the a, b, and the c, but you can't divide a 2 out of the d. You have to be able to divide that number out of every single one of these. All right? And if you can't, you leave it alone. All right? Okay, so I've handed you out this worksheet. And please don't lose it because we're going to use it for something else next week. Okay? I want you to balance these. You do not need to rewrite the equations on the line. Just put coefficients in front of the substances here in the actual worksheet. There's a typo on here, though, that I want to fix before we start. Okay? So, if you look at question number, number 9. Okay? Question number 9. You see how question number 9 says C8H18 plus O2 yields 1O2? That shouldn't be a 1. That should be a C. So let's fix that. That should, number 9, that should be a C. Okay? That's the only typo on here. All right, now, it should be a C, right? Okay, so I want you to balance these equations. You don't know how to identify the types. You won't know how to do that until Friday. And just go ahead and put numbers in front of these substances. Don't rewrite the equation. Leave this line blank because that's how we're going to identify things. Okay? You might find that you can do all of these, but you might find that number 9 is particularly tricky. Okay? Try it. If you don't get it, put a star next to it. Not a big deal. There's something about that particular kind of reaction that I haven't taught you how to do yet. Okay? And chances are that I won't until Friday.
How do you reduce to?
If you look at the coefficients, if all the coefficients can be divisible by some number, you divide it out. Okay? All right, so I'm going to turn the lights on. I want you to try these. And I'm going to put the key up on the screen, okay, so that you can check yourself as you work. If for some reason you're not getting the answers that I've got on my key, call me over and I'll help you. I'll hold your hand, all right?